Speed limits give you a baseline for managing speed. Posted speed limits are legal guidelines based on optimum road, traffic, and vehicle conditions. Posted speed limits can be too fast for foggy or icy conditions, or for rigs with heavy loads. It's up to you to assess each situation and adjust your speed for safe operation. Speed limits are not arbitrary numbers set up by the government. Many well-thought-out factors go into determining speed limits. These factors include sight distance, which is affected by hills, intersections, and road shape, road surface, space limitations, or available space based on amount of traffic and number of lanes, vehicle type, and illumination or available light. The speed limit also takes into account the amount of traffic on a roadway. When you're moving fast, you travel further before spotting and reacting to a hazard. Your overall stopping distance is increased, and your rig is more difficult to handle. Speeding simply limits your ability to cope with vehicle emergencies. The most obvious penalty for speeding is a traffic ticket. Traffic tickets cost money and points. Points can increase the cost of both personal and company insurance and can result in your license being revoked. Fatigue is another penalty of speeding, and its consequences can be costly. Speeding drivers generally become tired more quickly. Passing other vehicles and maneuvering through traffic is hard work. The noise and vibration of the cab is much more noticeable and can make you weary when you're driving fast. Plus, watching for police and worrying about tickets take a toll on your mental stamina. Speeding affects nearly every component on the rig. It lessens the life of your tires and increases the chances of tire failure. Brake wear from a rig going 70 miles per hour is much higher than one going 50 miles per hour. As speed increases, all vehicle systems have to work harder to maintain an even temperature. Heat means wear and tear on gears, bearings, clutches, suspension, transmission. Consider this. Maintenance costs go up 38% at speeds from 50 to 60 miles per hour. At speeds of 50 to 70 miles per hour, they go up a whopping 88%. Fuel costs increase as your speed increases. For maximum fuel efficiency, the ideal speed for rigs on today's freeways is 50 to 55 miles per hour. To maintain a cruise at 60 miles per hour, the vehicle needs 73% more horsepower. The required horsepower nearly doubles to 159% at speeds of 70 miles per hour. Consider fuel costs. A rig that gets 8 miles per gallon at 50 miles per hour gets only 7 miles per gallon at 60 miles per hour. That's an additional 12,500 gallons of fuel for every 100,000 miles. Multiply this by fuel cost, and you can see just how expensive speeding is. You're a trucker in the business of moving your load from one location to another. That's your job. When you're in the driver's seat, you need to respond to 100 different situations. And of all the situations you meet, being able to stop in time is the most important. And that's why it's critical that you always have a good idea of how much distance it will take your rig to stop. There are two parts to stopping distance: driver response time and vehicle brake time. How quickly do you need to react? Consider this. The same vehicle travels 59 feet at 40 miles per hour and 88 feet at 60 miles per hour. Here's an easy formula to estimate the feet your vehicle travels per second. First, note your traveling speed. Say it's 40 miles per hour. Divided by 2. 40 divided by 2 is 20. Add it to your traveling speed, 40 miles per hour plus 20. So at 40 miles per hour, your rig is traveling 60 feet per second. For you to stop at any speed, you need time to respond. Response time includes perception and reaction time. Perception is the time it takes to identify a hazard. Reaction is the time it takes the driver to decide what to do and follow through with the action. Let's look more closely at reaction time. The average driver's reaction time is 3/4 of a second. So if at 40 miles per hour you travel 60 feet per second, allow 45 to 60 feet for reaction time. At 50 miles per hour, you travel 75 feet per second. So if it takes you 3/4 of a second to react, in that 3/4 of a second, your rig has traveled between 50 and 75 feet. Let's look at how many feet per second a rig going 75 miles per hour will travel during driver reaction time. Effective braking distance is the distance the vehicle travels after the brake shoes make contact with the brake drums. Effective brake distance depends on several factors: your speed, the weight of your vehicle, the condition of your brakes and tires, and the air supply. Let's take a closer look at each of these factors. First, let's look at vehicle speed. It's quite simple, really. High speeds always equal longer braking distance. As a vehicle accelerates, energy builds up. It takes energy to stop energy. Vehicle weight also increases braking distance. It takes longer for heavier vehicles to stop. That's one reason that speed limits for trucks are often lower than they are for cars. Sometimes empty trucks need a longer braking distance than a fully loaded vehicle. Too little weight on the tires reduces traction and increases braking distance. Brakes, tires, springs, and shock absorbers are designed to work best for loaded trucks. Braking may cause an unloaded vehicle to jump up and down. Vehicle components directly involved in braking include the brakes, tires, and the air supply. Most important are the brakes themselves. Worn or misadjusted shoes, pads, or slack adjusters reduce brake performance. Worn tires have much less friction, which increases stopping distance, especially on wet roads. Well-maintained tires provide traction, essential for road friction for stopping. When choosing a safe speed, you must take the condition of the road surface into account, and that means understanding the role of traction. Traction is a type of friction that causes tires to grip the road. If traction is reduced for any reason, your stopping distance increases. If you have no traction, you lose the ability to control your rig. Road and weather conditions affect how much traction you have. A wet road nearly triples your stopping distance because traction is reduced. A vehicle driving 30 miles per hour on dry pavement takes 140 feet to stop. The same vehicle requires 444 feet on wet pavement. A vehicle going 60 miles per hour on dry pavement takes 531 feet to stop. At the same speed on wet pavement, the vehicle needs 1,353 feet to stop. Slippery surfaces can be deceiving. If you know what to look for, you can anticipate slick road areas. Pay special attention to icy roads. Shaded areas of any icy road stay icy longer. When the temperature is right around freezing, beware of bridges. The top and bottom stay frozen longer than the rest of the road. Watch for black ice. It's a thin layer of ice clear enough to let you see the road beneath. The road may look wet when in fact it's a very slippery surface of ice. To detect black ice, watch tire spray. If the spray disappears when the weather is cold, you may be on black ice. If there are no vehicles nearby, look for tracks in the water. No tracks could mean black ice. On any rainy day, when the temperature is near or below freezing, look for ice forming on your vehicle. If ice is building up, it's probably getting icy on the road too. Watch for hot days too. On a hot day, the first 10 to 15 minutes of rain cause dangerous situations, especially at intersections. Rain combines with oil and dirt to create a slick surface over the road. Asphalt roads are notorious for this problem. The oil tends to rise to the surface. This is called bleeding tar. Sometimes rain and oil get trapped between leaves and the surface of the road. It creates a very slippery and dangerous surface. Follow these guidelines to reduce road surface hazards. Don't apply the brakes. Decelerate gradually. Reduce speed on packed snow by 1/2. Reduce speed to a crawl on icy roads. If you've ever been water skiing, it's exhilarating and fun. If you've ever been hydroplaning in a tractor trailer, you know it's very frightening. Basically, a hydroplaning vehicle is out of the driver's control. If you're hydroplaning, you have no traction at all. There are two types of hydroplaning: dynamic hydroplaning and viscous hydroplaning. Dynamic hydroplaning is like water skiing. A thin film of water almost lifts your vehicle from the road, and you slide along the top. As you accelerate, the tires leave the road, and you're in fact road water skiing. Click Next to continue. Viscous hydroplaning occurs when a tiny amount of surface water combines with dust. You may not expect anything until you lose braking control or notice the vehicle suddenly shift direction. Reduce speed for water that is standing or running over the driving surface. Second, drive on good tires. Worn tires have less tread for water to flow through. Make sure the tires are inflated to the correct pressure all around the vehicle. Underinflated tires create more surface contact and less space for water to flow through. If your rig does start to hydroplane, remember 3 simple things. Decelerate gradually. Downshift with great care until speed is reduced to less than 20 miles per hour. Don't hit the brakes or turn the wheel until you regain control. Speed limits on curves and turns are typically set for passenger cars. They're often too high for big rigs. When your vehicle goes around a curve, the weight of your load has a tendency to go straight, and the higher your speed, the stronger the pull. When you encounter curves and turns, you need to take into account how the height and weight of your rig affects its stability. Compare the center of gravity of a truck with a passenger vehicle. It's much easier to operate a car, which rides closer to the road than a big rig. Skids generally occur from braking during a curve, so slow down at least 5 miles below the posted speed before entering a curve. Tests have shown that trucks with a high center of gravity can easily roll over, even at the posted speed limit for a curve. Half-filled tankers have an even greater tendency to go straight when you're negotiating a curve. The liquid is in constant motion, magnifying the effect of centrifugal force. And if the liquid sloshes up the sides over the center of gravity, it can cause a rollover. Dry tankers are also candidates for rollovers. With any type of load, follow these safe methods for entering curves or turns. First, anticipate the change in the shape of the road. Brake to a safe speed before entering a curve. Choose a gear that will let you accelerate slightly in the curve to help you keep control. Ease on the throttle as you drive through the curve at a steady speed. The correct procedure for climbing an upgrade depends on several factors: the type of drivetrain, the percentage of grade, and the type of load. Here are some guidelines for managing speed when you're going up an incline. Don't gun it up a hill. A smooth acceleration will minimize the risk of overheating. Select the proper gear to start. Keep an eye on all temperature gauges. Going uphill really works your engine. Be courteous. keep to the right to let faster vehicles pass. Use the truck lane if there is one. Be especially alert when you approach the crest of the hill. Remember to drive only as fast as you can see ahead. On downgrades, gravity boosts vehicle speed, which is especially dangerous for heavily loaded trailers. In the next few frames, we'll look at the damage that speeding downhill can cause. Overspeeding the engine 200 to 300 RPMs causes severe engine damage. Keep an eye on the tachometer and get control of your rig if the engine is overspeeding. If you allow speed to build up too much, the service brakes could be damaged because they can't get rid of the heat fast enough. The result is loss of braking ability. The result of engine and brake damage is loss of vehicle control. Here are some guidelines for managing speed when you're going down an incline. On long, steep grades, always select the proper gear. Conserve your brakes to ensure effective braking all the way down the grade. Your company will have a policy regarding the type of brake pressure to apply. Check to be sure. Time the shift to begin at the crest of the hill before you start your descent. In general, use the same gear or one gear lower as the one you use to go up a hill. This is a rule of thumb and will vary depending on the type and age of your rig. Downshifting during the descent is difficult and dangerous. You can get caught in neutral. You can also get caught between gears if you try to upshift on the descent. Your speed might increase before you complete the shift. Watch air system pressure. If the air system falls too low, brake failure or lockup could occur. It's important to adjust your speed based on how far you can see ahead. The fundamental rule is to be sure you can stop safely within the distance you can see. When weather, light, or road conditions reduce visibility, reduce your speed. At 55 miles per hour under normal conditions, you need about 450 feet to stop. That's as long as 1.5 football fields. Speed affects your field of vision. The faster you drive, the less you can see to the sides without turning your head. At 20 miles per hour, you can see about 102 degrees around your head. At 40 miles an hour, your field of vision is reduced by about 70 degrees. And at 60 miles per hour, it drops to 42 degrees. So the faster you go, the less you see to the sides, and the less time you have to react to hazards as they come into your field of vision. Speed affects your field of vision. The faster you drive, the less you can see to the sides without turning your head. At 20 miles per hour, you can see about 102 degrees around your head. At 40 miles an hour, your field of vision is reduced by about 70 degrees. And at 60 miles per hour, it drops to 42 degrees. So the faster you go, the less you see to the sides, and the less time you have to react to hazards as they come into your field of vision. Darkness is the most common condition that reduces the distance you can see ahead. If you're not within 500 feet of oncoming traffic, use your high beams. Then you can resume a 55 mile per hour speed. Plan for extra time to allow for safe night driving. In the bright of day, sun glare also poses a big problem. It cuts down sight distance and the glare hides hazards. Hills and curves can seriously restrict the distance you can see. At intersections, trees, bushes, or buildings can block your view. Other vehicles, bicycles, and pedestrians can suddenly appear out of nowhere. Drive slowly enough so you can react to these situations. Anything that reduces your visibility should alert you to reduce your speed. Use this chart as a guideline for visibility and stopping distance. There are two main mistakes drivers make in traffic: going too fast or going too slow. Plan ahead so you aren't in a hurry and tempted to speed. Because you drive a big rig, drive defensively. Don't use your size to bully other vehicles out of the way. Watch your speedometer on downhill inclines so you don't build up too much speed. But don't go too slow either. It can be as dangerous as going too fast. Always keep to the right when going up a hill to allow faster-moving vehicles to pass. If traffic builds up behind you, you may want to pull off. But beware, pulling off and re-entering the flow of traffic can be more dangerous than staying with it. Here's the best way to enter traffic. Use your signals to indicate your intentions. Merge as quickly as possible to avoid reaching the end of the access lane. Watch your mirrors. Many vehicles will change lanes or slow down to let you in. Adjust your speed to the flow of traffic. Enter traffic as soon as a gap is available. Watch for drivers who may be nervous of big trucks and act in sporadic ways to a merging rig. Exit ramps are a frequent accident site for trucks. Sometimes the curve is too sharp for your speed. You may not be able to see the entire ramp layout. The beginning may be easy, but the end very tight. Use caution until you can see the entire ramp. With long hours on the road, it's easy to misjudge your speed when you're exiting a roadway. You may experience velocitization. That's a word we use to describe this situation. When drivers have maintained the same speed for a long time, they get used to the faster speed and feel like they're going slower than they actually are. Be especially careful of velocitization when you exit a highway, on turns, curves, and bends. Here are some guidelines to follow when you exit a freeway. Reduce your speed slowly to avoid a rear-end collision. Enter the exit lane as early as possible. Slow to the appropriate speed for the ramp. Use regulated braking to prevent a skid. Adjust your rig's speed to the flow of traffic. Finally, be aware of velocitization. Always use your speedometer for a reality check.